Digestive enzymes. Digestive enzymes. Enzymes which are usually proteins aid in and accelerate every chemical reaction in the human body. Enzymes are the body's main workforce. Enzymes are, in essence, the substances which make life possible. To ensure our survival, our bodies must have the necessary ingredients. Our bodies must have enzyme activity factors with which it can continue to create enzymes. When your body loses the ability to produce enzymes, you cease to exist. Cooked food diet. These days people eat a primarily cooked food diet. 99% of these foods are cooked at temperatures of 212 degrees or more. When food is cooked at these temperatures, the enzymes in it are 100% destroyed. If enzymes were in the food we eat, they would do some, or even a considerable part of the work of digestion by themselves. However, when you eat cooked, enzyme-free food, this forces the body itself to make the enzymes needed for digestion. This depletes the body's limited enzyme capacity. It's one of the paramount causes of premature aging and early death. I also believe it's the underlying cause of almost all degenerative disease. If the body is overburdened to supply many enzymes to the saliva, gastric juice, pancreatic juice, intestinal juice, then it must curtail the production of enzymes for other purposes. If this occurs, then how can the body also make enough enzymes to run brain, heart, kidneys, lungs, muscles and other organs and tissues? When you consume high-temperature cooked foods, your body must steal enzymes from other organs in your body, the heart, brain, kidney, lungs, etc. These ensuing metabolic dislocations, enzyme deficiencies, can be directly linked to chronic incurable diseases including cancer, heart disease, diabetes and many more. The majority of people alive today suffer from enzyme deficiency stress. This is a direct result of not adding raw foods to our daily diets. This stealing of enzymes from other parts of the body to service the digestive tract sets up a competition for enzymes among the various organ systems and tissues of the body. The resulting metabolic dislocations may be the direct cause of cancer, coronary heart disease, diabetes and many other chronic incurable diseases. This state of enzyme deficiency stress exists in the majority of persons on the civilized, enzyme-free diet. Also, we know that decreased enzyme levels are found in a number of chronic ailments, such as allergies, skin disease, and even serious diseases like diabetes, cancer. Furthermore, there is research showing that almost 100% of the people over 50 dying from accidental causes were found to have defective pituitary glands. I believe that food enzyme deficiency is the cause of the exaggerated maturation of today's children and teenagers. It is also an important cause of overweight in many children and adults. The human pancreas. The human pancreas is burdened with enzyme production far in excess of any creature living on a raw food diet. In fact, in proportion to body weight, the human pancreas is more than twice as heavy as that of a cow. Human beings eat mainly cooked food, while cows eat raw grass. Moreover, evidence shows that the human pancreas is one of the heaviest in the animal kingdom when you adjust for total body weight. This over-enlargement of the human pancreas is just as dangerous as an over-enlargement of the heart, the thyroid, and so on. The overproduction of enzymes in humans is a pathological adaptation to a diet of enzyme-free foods. Salivary glands. The pancreas is not the only part of the body that oversecretes enzymes when the diet is cooked. In addition, there are the human salivary glands that produce enzymes to a degree never found in wild animals on their natural foods. In fact, some animals on a raw diet do not have any enzymes at all in their saliva. The cow and sheep produce torrents of saliva with no enzymes in it. Dogs, for instance, also secrete no enzymes in their saliva when they're eating a raw diet. However, if you start giving them cooked starchy food, their salivary glands will start producing starch-digesting enzymes within 10 days. In addition, there's more evidence that the enzymes in saliva represent a pathological and not a normal situation. For instance, salivary enzymes cannot digest raw starch. This has been demonstrated in the laboratory study. The enzymes in saliva will only attack a piece of starch once it's cooked. Therefore, we see that the body will channel some of its limited enzyme-producing capacity into saliva only if it has to. Therapeutic fasting. The most impressive evidence that people need enzymes is what occurs as a result of therapeutic fasting. When a person fasts, there is an immediate halt to the production of digestive enzymes. The enzymes in saliva, gastric juice, and pancreatic juice dwindle and become scarce. During fasting, the body's enzymes are free to work on repairing and removing diseased tissues. Civilized people eat such large quantities of cooked foods that their enzyme systems are kept busy digesting food. As a result, the body lacks the enzymes needed to maintain the tissues in good health. Most people who fast go through what is called a healing crisis. They may feel nausea, vomiting, and dizziness. What's happening in the enzymes are working to change the unhealthy structure of the body. The enzymes attack pathological tissues and break down undigested and unprocessed substances, and these then get thrown off through the bowels through vomiting or via the skin. When people get enzymes from food, aren't they destroyed by stomach acid? Although most nutritionists claim that enzymes in food are destroyed in the stomach, they overlook two important facts. First of all, when you eat food, acid secretion is minimal for at least 30 minutes. As the food goes down the esophagus, it drops into the top portion of the stomach. This is called the cardiac section since it's closer to the heart. The rest of the stomach remains flat and closed, while the cardiac section opens up to accommodate the food. During this time, the food sits in the upper section. Little acid or enzymes are secreted by the body. The enzymes in the food itself go about digesting the food. The more of this self-digestion that occurs, the less work the body has to do later. When this 30 to 45-minute period is over, the bottom section of the stomach opens up, and the body starts secreting acid and enzymes. Even at this point, the food enzymes are not inactivated until the acid level becomes prohibitive. You see, food enzymes can tolerate chemical environments many times more acid than neutral. Good source of digestive enzymes: pineapple, papaya, mango, honey. In general, foods having higher calorie content are richer in enzymes. Digestion. Anti-nutrients in foods. Nutrients in plants are not always easily digested. This is because plants may contain anti-nutrients. These are plant compounds that reduce the absorption of nutrients from the digestive system. They are of particular concern in societies that base their diets largely on grains and legumes. The most widely studied anti-nutrients include protease inhibitors, interfere with protein digestion by inhibiting digestive enzymes. Phytate reduces the absorption of minerals from a meal. These include iron, zinc, magnesium, and calcium. Tannins, a class of antioxidant polyphenols that may impair the digestion of various nutrients. Lectins are a diverse family of carbohydrate-binding proteins found in all plants and animals, but the highest amounts are found in legumes and grains. Some lectins may be harmful in high amounts and interfere with the absorption of nutrients. Calcium oxalate, a primary form of calcium in many vegetables, such as spinach. The calcium bound to oxalate is poorly absorbed. There are some food seeds and nuts that contain what are called enzyme inhibitors. These enzyme inhibitors are present for the protection of the seed. Nature doesn't want the seed to germinate prematurely and lose its life. It wants to make sure that the seed is present in soil with sufficient moisture to grow and continue the species. Therefore, when you eat raw seeds or raw nuts, you are swallowing enzyme inhibitors which will neutralize some of the enzymes your body produces. In fact, eating foods with enzyme inhibitors causes swelling of the pancreas. All nuts and seeds contain these inhibitors. Raw peanuts, for example, contain an especially large amount. Raw wheat germ is also one of the worst offenders. In addition, all peas, beans, and lentils contain some. Potatoes, which are seeds, have enzyme inhibitors. In eggs, which also seed, the inhibitor is contained mainly in the egg white. As a general rule, enzyme inhibitors are confined to the seed portions of food. For instance, the eyes of potatoes. The inhibitors are not present in the fleshy portions of fruits or in the leaves and stems of vegetables. How to reduce anti-nutrients in foods. 4 methods to reduce anti-nutrients in foods: soaking, sprouting, fermentation, boiling. Soaking. Beans and other legumes are often soaked in water overnight to improve their nutritional value. Most of the anti-nutrients in these foods are found in the skin. Since many anti-nutrients are water-soluble, they simply dissolve when foods are soaked. In legumes, soaking has been found to decrease phytate, protease inhibitors, lectins, tannins, and calcium oxalate. However, soaking reduces protease inhibitors only very slightly. Not only is soaking useful for legumes, but leafy vegetables can also be soaked to reduce some of their calcium oxalates. Soaking is typically used in combination with other methods, such as sprouting, fermenting, and cooking. Sprouting. Sprouting is a period in the life cycle of plants when they start emerging from the seed. This natural process is also known as germination. This process increases the availability of nutrients in seeds, grains, and legumes. Sprouting reduces phytate in grains and legumes and may slightly degrade lectins and protease inhibitors. Fermentation is an ancient method originally used to preserve food. It is a natural process that occurs when microorganisms, such as bacteria or yeasts, start digesting carbs in food. Although food that becomes fermented by accident is most often considered spoiled, controlled fermentation is widely used in food production. Food products that are processed by fermentation include yogurt, cheese, wine, beer, coffee, cocoa, and soy sauce. In various grains and legumes, fermentation effectively degrades phytate and lectins. Boiling. High heat, especially when boiling, can degrade anti-nutrients like lectins, tannins, and protease inhibitors. In contrast, phytate is heat-resistant and not as easily degraded with boiling. The cooking time required depends on the type of anti-nutrient, food plant, and the cooking method. Generally, a longer cooking time results in greater reductions of anti-nutrients. However, foods are cooked at temperatures of 212 degrees or more. When food is cooked at these temperatures, the enzymes in it are 100% destroyed. That's why soaking, sprouting, and fermentation is preferable. Sprouting destroys the enzyme inhibitors and increases the enzyme content from a factor of 3 to 6. Some foods, like soybeans, must be especially well heated to destroy the inhibitors. For example, many of the soy flours and powders on the market were not heated to destroy the inhibitors. If the body is unable to make enough digestive enzymes, food molecules cannot be digested properly. This can lead to digestive disorders like lactose intolerance. Digestive enzymes are necessary as they break down molecules like fats, proteins, carbs into even smaller molecules that can be easily absorbed. There are 3 main types of digestive enzymes. Proteases break down protein into small peptides and amino acids. Lipases break down fat into 3 fatty acids plus a glycerol molecule. Amylases break down carbs like starch into simple sugars. Combination of methods. Combining many methods can reduce anti-nutrients substantially, sometimes even completely. As an example, soaking, sprouting, and lactic acid fermentation decreased the phytate in quinoa by 98%. Similarly, sprouting and lactic acid fermentation of corn and sorghum degraded phytate almost completely. In addition, soaking and boiling pigeon peas led to a 98 to 100% reduction in lectins, tannins, and protease inhibitors. Conclusion. When food is cooked, the enzymes in it are 100% destroyed. Eating foods with enzyme inhibitors causes swelling of the pancreas, and enzyme inhibitors neutralize some of the enzymes your body produces. The overproduction of enzymes in humans is a pathological adaptation to a diet of enzyme-free foods and eating foods with enzyme inhibitors. The enzymes in saliva represent a pathological and not a normal situation. This depletes the body's limited enzyme capacity. When your body loses the ability to produce enzymes, you cease to exist. Enzyme deficiencies can be directly linked to chronic incurable diseases including cancer, heart disease, diabetes, and many more. It is also an important cause of overweight in many children and adults. Soaking, sprouting, and fermentation leads to a significant reduction in antinutrients such as protease inhibitors, phytate, tannins, lectins, calcium oxalate. Eating foods that are high in natural digestive enzymes with reduced anti-nutrients content can help improve digestion and may have a tremendous effect on your health overall. That can also help to fix metabolic functions and to lose weight. Learn more about your daily diet